So let's look at this part 2 video of linear regression. So in this example, the heights and weights of 11 men between age 21 and 23 are measured. The data are present in table below. Use your graphing calculator. In this case, we're going to use online graphing calculator to obtain a scatter diagram of data. Comment on if the data appears to exhibit no relationship, linear or nonlinear. If it appears to be linear, classify positive or negative. So what you do is using this calculator, links available on Canvas, you type the values here. So I let it type here to save time in the video. So you just type all the x values. So I type 75 and 187, 66, 151, 71, 183. So I type all these values. So then make sure to scale it right. You can go zoom in, zoom out. Let's stay maybe like here. Zoom in a little more. So these are all the data for this problem. So here it appears that it's linear, right? Not only that, it's also positive. As x increases, y increases, which means slope is positive. So here we can say that this is positive linear association. And if you go down here, if you click this circle, it's already probably selected as a default. But I want to deselect it to show you the scatter plot without the line. This is the least square line we talked about in part 1. This is the best fit line. And here's the equation. Well, for example, here's the R is the coefficient. So R is 0.9142. So that means since it's close to 1, it exhibits strong linear relationship for this data set. It also gives us the equation. The y1 here is the same thing as y hat that we talked about, the predictor, the predicting y hat is mx, m is the slope, plus b. So we can use this equation for this data. We can write y hat equals 5.731x plus, or I guess in this case, minus 203.58. That is the equation that describes this line with the best fit. And we can use this equation with this number to predict it, let's say, some other height. I want to predict if someone is 65 inches, what will be the weight? We can use this equation. We can plug numbers here to find that out. Okay. So that's how I'll do example 1 using this calculator. And let's look at example 2. Yeah, so I guess I already kind of talked about it. Here, now actually just write down the R value right here, 0.9142. And even looking at the linear coefficient without the graph, we can tell that the letter is going to be positive because positive number. And because it's close to 1, it's strong linear. So first, we have a linear relationship because this number is close to 1. And because it's positive, it's strong positive linear relationship. If the R you get here is, let's say, 0.01 or even 0.1, although that number is positive, it does not mean that it's a linear. Because it's close to 0, it's no linear relationship. Yeah, so here it says, same data, find the height of 72 inches tall. So how do we do this one? So what we do is we type this data into this graphing calculator and you write down the equation using these numbers. So it gives us a slope and y-intercept. So let's write y hat equals 5.371 plus negative 203.58, or we can just write minus 203.58. So we write it like this. So this is the equation, least square equation for this data set. And since we want to predict at x equals 72 inches, sorry, what we do is right here, we plug 72 inches. So for the final answer for that problem, I want to predict the height, I want to predict weight of a person whose height is 72 inches. So you do this calculation, okay? And then they'll give us the predicting value of the response variable y. So this gives us 183.132. So in this problem, we predicted that person with a 72 inches have 183.132. And as you can see, it's a little off from the actual data we observed. We have two data sets for 72 inches tall. Okay. So linear regression can help us predict. It's not always going to be exactly the same value, or it doesn't guarantee it. But stronger the R value, more reliable this equation is, this equation. Okay? So let's look at this problem together. When you open the calculator, you already have these numbers in. So don't worry about these numbers. You can just type over it. So I'm going to type x 3735. And you can use the arrow key to go down. So you can type all the x values first. Make sure you don't miss one though, because it's very important that you keep all the numbers. Oops, 2606. Okay, so I type all the x values. Then for y values, 17, 16, 25, 19. Like that, okay? And as you can see, you don't see anything here, right? Because scale is different now. So scale, these are in thousands, like 2,000s, where y's are very way smaller number, right? So if you go down here, you have to go all the way to 1,000, or you can just zoom out. Data are here. Okay, so here's a. If you uncheck this line, oops, sorry. If you uncheck it, it will show just the scatter plot. We can also change the scale if you want. If you click this, let's see how that did. Yeah, if you click this with shift, and if you bring it over, you can change the scale. Okay, just easier to see a little bit, like that. Okay, but then let's click this to see the best fit line. This is the least square regression line. And again, it gives us the equation. The m, the slope is negative. Negative means it's just negative relation. When one increases, other value decreases. And y-intercept, b value is 42. So we plug in here to find the values. And r is negative 0.9596, which is pretty strong negative. It's close to -1, so it's yes, negative. So here the scatter plot itself shows actually it does have linear regression, linear correlation, and it's negative even without the R value, right? So that's what the answer for is negative and linear for A. For here, find the correlation coefficient, which is negative 0.9596. You just read it from here. That's why you write. And the equation, what's the least square regression equation? Y hat, the same thing as y hat, equals m, put slope here, plus b. So let me actually write that in here so we can work with it. Y hat equals negative 0.0069x plus y-intercept was 42, forgot the number, 9.9068. And sometimes we write this first and this second. Again, addition order doesn't matter, so which term you write first doesn't matter. You just have to focus, make sure where the x is, because that's the variable that we plug it in, right? So that's the equation. Use this equation to predict MPG for a car weighing 3,800 pounds. So I guess this context of this problem, I forgot to mention, is that they want to see, engineer want to see determine how the weight of a car affects gas mileage. The following data represents the weight and miles per gallon. So we want to know if a car weighs 3,800 pounds, what will be the gas mileage using this model. Okay. So all I do is to find the predicted value, just find the 3,800 right here. Plug 3,800, multiply by that number, this number, make sure that it's negative, and add 42.9068. and that gives me about 16.69. In this case, all the answers are whole numbers, so it's about 17 miles per gallon. So we can predict that the car that weighs 3,800 pounds, a gas mileage of 17 miles per gallon, according to this data. Okay, so that's how we use this calculator right here. Okay, so the focus is really interpreting the R value and using the equation. Right? Since you're not calculating the equation on your own, you're just reading up from the calculator, right? So how to use it? Just plug the value to predict a certain value. So lastly, I want to look at one homework problem together. So just know that how we can use technology, this calculator. So here's a problem from homework. Draw a scatter plot. So you can type this data into this calculator, which I already did right here, all the x values or the y values. Let me do this. So then it plots for us. Since it's only S for scatter plot, you can uncheck this button to just see the scatter plot. Okay, and it's multiple choice, so scatter plot is this one. And this appears to be, right now we're just relying on our eyes. This appears to be a linear negative, right? With this language specific is intentional. It appears to be, right? In order to be sure, we have to look at the linear coefficient. So here, ask us to write the equation, mx plus b. Well, m is right here, so type this number, 3 decimal place. Oh, I'm sorry, you kind of cut off in your screen. Okay, so here y hat equals mx plus b. Find the slope. Well, we know the slope right here is negative 0.06902. So let me type that. Okay. 90. Y-intercept is 6.397, but rounding 3 decimal, so 6.398. Okay, so just type numbers from here. So B, they ask us to use this number, you can ignore it. Just use the calculator provided. Okay. So which one is the correct graph? Then from here, you check this again to see the line, the best fit line, which is B right here. Okay, this one. Just make observation how this is similar to this. Okay. Yeah, so that's how you do these problems. Okay. This calculator gives us least square regression line and also the R value. Don't worry about R square, it's just squaring number, but we're focusing R, how to interpret R. So all these homework problems, you can use this calculator. Here also you can click this. Let's see. Yeah, just use this calculator to do the sum of the homework parts. But again, the thing that you will need to focus on is how to interpret R, which we talked about in the first part. Let me go right here. How to interpret R. Right here. And so interpreting R means first, R tells us whether there's a linear relationship or not. If it's close to 1, close to -1, there's a linear. 0.5, yeah, negative 0.5, there's a linear. But it's a weak or strong, or weak or strong can be determined by how close to 1, -1. If it's close to 0, like 0.01 or 0.1 even, we can say there is probably no linear relationship. If it's perfect, just 0. If R equals 0, no linear. Close to 0, we can say no linear relationship. Like here, R is close to 0. So don't just focus on positive, negative. Here, R could be negative 0.01, negative 0.09, R is. But that doesn't mean we have negative linear automatically, right? So it's very important to pay attention. Here, the R could be 0.02. That does not mean we have positive linear, because number itself is close to 0. So always look at the magnitude of number. Okay. So focusing on R, and second thing is how to use the equation, like in where did it go? I did it here. Just plug in the value to find the predictor value.